Hey everyone, let's continue our conversation on adding vectors. We're going to do a couple of different methods here today, the tip-to-tail method and the parallelogram method. And we're going to find they're really not very different. They're just kind of a different way of looking at the same thing. And in the end, they'll basically look the same. All right, so let's start with tip-to-tail. So let's say I've got a vector, I'm going to travel a path again. And so I'm going to have some vector A. And then I'm going to add to that another vector. I'm going to go out along a different path here. And I'm going to follow this path B. So I'm going to walk this path and I'm going to walk this path. In the end, then, my final displacement is the sum of these two vectors, the sum of A plus B. And so it's going to be this vector here. And I'm just going to write that as A plus B. All right, and the reason this is called the tip-to-tail method is that you draw the first vector A, and then from the tip of A, you put the tail of B, and then you draw the vector B, proper length, proper direction in both cases. And then you start at the tail of A, and you go to the tip of B. And that would be the net vector, or the sum of those two vector quantities. The sum of those two vector quantities. And so there you have A plus B. So pretty simple. We'll do this mathematically later. But if I were to do this on a piece of graph paper, the way I would do this is I would draw the vector A, and I would need to know something about its size and its direction. And so I would draw the vector in the proper direction. Maybe that requires a protractor. And I would draw it at the proper size, and that might require a ruler. And then once I draw A using a protractor and a ruler, I would then put my protractor and ruler at the tip of A, and I would draw B, proper length, proper direction. And then I just draw with a ruler from the first point to the last point, and that's my summation of those two vectors. All right, so that's basically the tip-to-tail method. And then the parallelogram method works very similarly, except in the parallelogram method, we generally draw the two vectors tail to tail. All right, and so I'm going to have the first vector would be A. All right, so there's vector A. And then from the tail of A, I'm going to draw B. And so there's B. I don't know that that's exactly the same as this A and B, but we'll go with it. And then what I do is I create a parallelogram. All right, and so what I need to do is I need to create a side. There's two sides of the parallelogram, right? The parallelogram has four sides and they're parallel. The two opposite sides are parallel. So I need another side over here, and that side's got to be the same as A. Right? So the same length, right? It's going to be the same length. I'm not the best of artists. And in the same direction. And then I draw another side parallel to B and the same length. And so there's B. If I was a good artist, that would be a parallelogram. What does that mean? This length equals that length. This length equals that length. Okay? Then they're also parallel, which means that this angle in here, this angle right here, I'll call that theta. That's going to be the same as that angle over here. So that's also going to be theta. And this angle over here is going to be some angle phi. And this will be the same angle phi. All right, I'm not going to worry too much about those those angles, but the idea here is that these two sides are parallel. The purple sides and the blue sides are also parallel. They point in the same direction, right? Again, what defines the vector A? Its length and its direction. So these are the same length and they're the same direction. They're just not lines aren't drawn at the same location. But if they're in the same direction, they must be parallel. All right, so let's forget about those for a second, especially the theta. And then let me say then that to find the sum of these vectors, you draw the diagonal from where the two vectors' tails came together to where the two vectors' tips come together. And so this, ooh, that's terrible. This is A plus B. Okay, let me draw that a little better. this is A plus B. So the diagonal starting at the origin where we started our two vectors, so the opposite side, the diagonal goes from one corner, excuse me, to the opposite corner. That's going to be the summation A plus B. All right, so that's another way of drawing the sum of two vectors. Well, this really isn't much different than this over here, because if you think about it, I could have started, instead of taking path A first, I could have taken path B first. Okay, so that might end up, I can draw that a little better. And then we take path B, again, tip to tail, right? Tip to tail, this is path A. I think I said path B. This is path B, so we do path B first in this case, and then path A, and we end up at the same place. Okay, we end up at the same place. And this actually says a lot, because this tells me that A plus B is the same as B plus A. So adding vectors is commutative. When I sum vectors together, that is a commutative operation. The summation of vectors is a commutative operation. Okay, so there's adding vectors tip to tail, and here is adding vectors using the parallelogram method. All right, so there's a pretty good review. We'll continue adding vectors in more videos. All right, if you have any questions, please leave them in the comments below. Thank you.